Hey folks, welcome to the channel. This is the first video in the series we'll be learning about binary search tree. In this video we'll be learning about the basics of the data structure, and in the corresponding videos we'll be learning about different algorithms which we can do on a binary search tree. So let's get started. So the binary tree or a binary search tree is made up of constituent elements called nodes. So we need to first understand a node before we can understand how a binary search tree works. So I'm going to bring up an example here. So let's say you have a node. Let's say this node is node 1 and there's a node 2, there's a node 3. Okay. So first let's focus on what is a node and how it can be used to make a binary search tree. So I'll write it in terms of a program so that we can understand it better. So you can imagine it as a class node which have three properties. One is value, second is a left child, and third is a right child. So what are these values? What can be the values of these three properties? So the value can be a number, the left child and the right child. They are nodes. So node is essentially an object which holds these three attributes. So if you see our first node, let's say the value of this node is equal to a number 4. The right child that this node is pointing to is the node number 2, right? So the value of this left child will be node number 2, and the right child it's pointing to is node 3, and the value is 4. So this is how a node is defined. Similarly, if you look at node number 2, the value of this node, let's say, is 3. So its value is 3. Left child is none, or you can say null because there is no left child, and similarly right child is also null. So this is how a node is defined and how it's connected to make a binary search tree. Now if we go and look at this tree, I'm gonna write some more nodes here. So let's say there's a node 4 here, there's a node 5 here, node 6 and node 7. So now we need to understand some terminologies about this binary search tree before we can dig further. So the first node in a tree is called a root node. So this one is a root node. The nodes which don't have any child are called leaf nodes. So if you see these 4, 5, 6, 7, they don't have any other further childs. So all these are leaf nodes. So the levels. The root node is on level 1. Let me change the color here. So root node is level 1. Then you have level 2, level 3, and so on. So now we know what a node is, how these nodes are connected to each other to form a binary search tree, and we know what a root is, what a level is, and what a leaf is. Okay, moving on to our next page. Now the one we discuss here is just a general tree. Okay, so what makes it a binary tree? That it have maximum 0, 1 or 2 children. So if a tree have more than 2 children, it's not a binary tree. Okay, and what makes it a binary search tree? That it have to be a binary, and the second condition is the left subtree of any node should have less values than that node, and third condition is the right subtree of any node should only have more values than that node. So I'm going to go ahead and draw a binary search tree, and then we'll discuss these three properties. And I'm going to write the values of these nodes inside the circles only. We'll go one by one on these conditions and we'll see like if this is a binary search tree or not. Okay. So the first condition is that it has to be a binary tree. So if you look at all the nodes in this tree, right? This node, this node, this node, all these nodes, it's like none of these nodes have more than two children. So it's a binary tree. We can say that. Now we need to check if left subtree of any node have values lesser than that node. So what this mean? Let's see at this node 10. The left tree of this node is this entire structure, and the right tree of this node is this entire structure, right? So if you see at this subtree, right, this is your subtree. If you see at this, all these values are less than 10. Similarly, on this side of the subtree, all the values are more than 10. So we can say for this node, these two conditions are satisfied. Condition 1 is satisfied, condition 2 is satisfied, condition 1 is satisfied, and condition 3 is satisfied. All these three conditions are satisfied. Now we need to check these three conditions for all of the nodes before we can say that it's a binary search tree. So if you look at node 8, 4 and 6 are the subtrees, and these values like 4 is less than 8 and 6 is actually less than 8. It's not more than 8. So this does not satisfy the condition. So from here only we can say that it's not a binary search tree, not a BST, right? And if we need to dig further, let's say this 12. So the left subtree is just this element 11, and the right subtree is this entire thing, right? Now if you see on the left side, it's just 11, so it's less than 12. So that means it satisfies the first condition, it satisfies the second condition. But if you look at the third condition, on the right side, you have a node 11, which is lesser than 12, and it can't be. So your third condition is not satisfied. I'm going to just fill in the data for 8. So first condition is satisfied. Second condition is satisfied, but the third condition is not satisfied. So this is how we check if it's a binary search tree or not. Okay, so moving on, we need to understand what a balanced tree and what is an imbalanced tree. So for a balanced tree, all nodes have to satisfy this condition, which is that your subtree have same number of nodes on both sides. Okay, so what I mean by that is, let me draw a tree. It can be a valid BST. Now if you look at the node 1, and this is your left subtree and this is your right subtree. On the left side you have 3 elements, but on the right side you just have 1 element, so it's imbalanced, right? Now let me try to build a balanced tree here. So we have a 1, we have a 2, we have a 3, we have a 4, 5, 6 and 7. Now if you see, on both sides of 1 there are 3 elements. Similarly, if you check for node number 2, on both sides of 2 there are just 1 elements. If you check for 3, 6, 7, 1 elements. If you check for 4, there are no elements. Same for 5, same for 6, same for 7. So all these nodes are satisfying this condition. So we can say that this is a balanced tree. Alright. So this is all for this video. Let me just summarize. So we first understood what a node is, what are the 3 properties that a node have, and how can you write it in a program. Second is how these nodes are connected to each other to form a tree structure. And then in a tree, you need to understand what a root is, what are different levels, and what a leaf is. Going forward, we understood that in a binary tree, each node can have maximum of 2 children. And for a tree to be a binary search tree, it needs to be a binary tree. Like these 3 conditions are to be satisfied by all nodes, right? All nodes should satisfy these. So it have to be a binary tree. The left subtree can only have lesser values, and the right subtree can only have more values than the node that you're looking at. So when I'm looking at 10, the nodes on the left side of 10 should have only the less values. Then we went through discussing like of all these nodes, which one are satisfying these conditions and which one are not. Moving forward, we discussed what a balanced tree is and what an imbalanced tree. So for a balanced tree, the number of nodes on the left side and the right side have to be same for every node. And if it doesn't satisfy this condition, it's an imbalanced tree. All right, thanks for watching this video. I hope it helped you in understanding the basics of a binary tree. I'll be attaching these notes in the description so you can get them from there. Thanks. Please subscribe to the channel to get more videos in this series. Thanks.